And as the wonderful music of Alexander Brandon fades out, welcome and a very good evening to Technoclub. Sorry, I'm just muting my phone. It always goes off just when I want to record. It's terrible. Anyway, I hope everyone's doing well. You're having a lovely evening. I thought today we'd do a little bit of pathfinding. And pathfinding is all about, well, finding paths. And it's really important. It's important in sat-navs. It's important when you're designing non-player characters or NPCs in a video game. And it's a huge area of computer science. And we're going to do a very simple form of pathfinding. And as it shows you on the screen, we'll be using arcade.makecode.com. You should see something like this when you open it up. arcade.makecode.com. Once you've got that open, you can click New Project and give your project a good name. So this is going to be my Perilous Pathfinding. That'll do. It's only a little bit of fun experimental code. It's not a full game. It doesn't need a proper name. So I keep coming back to arcade.makecode.com, mostly because it's one of my favourites. I'm just going to go ahead and hide the simulator, because we don't need that for the moment. What we want to do today is we want to create a autonomous little sprite that can navigate through a maze on its own. No control from the user. It just does it by itself. It's fully autonomous. And so to do that, well, we're going to need a sprite to move about. So if you go to sprites, we can get the create a sprite block, the set my sprite to sprite of kind player. And we can stick that in our on start block. So this happens when the program starts. And in this bubble, if I click on it once, I get to draw the little character that's going to be running around the maze. You could do a hamster, you could do whatever you want. You could actually physically draw it. Or if you go to gallery at the top, we can pick one that's already been made for us. So if you like, you can have a piece of food going around your maze, you could have a duck, you could have a human. I'm going to go for, what should I have? They're all quite dull. I'm going to go for, let's have this cat. This cat's going to be what goes through my maze. I'm just going to click done on that. So I've created a sprite. And there it is in the simulator, just sort of sitting there, right in the middle. That's all we need from that. But we need a maze for this character to move around in. So that means we're going to use a tile map. Now, a tile map is a special type of background where it uses tiles on the background rather than just a picture. It means it gives you more control. It's quite nice to work around with. So if you go into Scene and scroll down, you can find this block called Set Tile Map to Blank. And that's what we're going to do. We want to set our tile map. So I'm going to drag that in. And if I click in the grey square, I get to draw my tile map. And it takes us to the tile map editor. So this is where we're going to draw our maze. Now, it's very important that we pick a floor tile. This is going to be the tile that shows our character what they can walk on. So we need to pick one and only one floor tile. So down here in the bottom left is the tile browser. You can find all the different tiles used. That's just the forest tile map though. If you click the drop down box above where it says forest, you've got an aquatic tile map, a dungeon tile map, and a miscellaneous tile map. Now, yeah, you're most likely to find a maze in a dungeon, I reckon. You know, in video games. And from this, we need to select what's going to be our floor. So having a little browse, we've got lots of walls in here. We've got stairs. I've got sort of tiled concrete flooring. Can have it cracked a bit. I'm going to choose this sort of grey, purpley dirt. That's going to be my thing. And I want this to cover the whole thing. So I'm going to use the fill tool and fill the whole screen with the floor. We get the floor down and then we draw the walls on top. Right, let's get to drawing the walls. Now, the beautiful thing about a tile map is it's quite often designed so that tiles next to each other have the same kind of, they connect, they form a good, solid continuation. So let's start by making a room up in the top left-hand corner. I'm going to start with a corner block. Oh, that was a mistake. I'm still on fill mode. I need to change back to pencil mode. Let's click undo, which you can find in the bottom right. And let's change back to paint tool. I want a corner in the top left. Let's make a bit of a sort of room. Another corner, and then I need 2 downs. And then another corner. No, let's make that a larger room. If you right-click, it'll erase a tile for you. Let's just make that a tad larger. You don't have to use the dungeon tile set. You could draw your own, or you could find one of the other ones. I quite like this one. It's got a nice colour palette. It's quite, it's quite easy on the eyes, at least for me. Now, making sure that every bit of flooring definitely has this purple floor tile, and the same one every time. I've got a room. Let's add a little exit to it. Let's round off those corners a bit as well, shall we? Let's go. We're going to use an internal corner this time. And then internal corner there. Now we could have that go along. And then kind of have the same on top. And yeah, let's start by putting our first corner in. The first corner that our computer player that we're designing is going to turn. Down like that. And then if we put an internal corner there, then okay, there we are. We're just showing the basics. We're not going to draw the whole map right now, because that's going to take ages. But there's one thing we need to do before we can carry on. We can look at these and we can know that these are walls, but how does a computer know that they're walls? It doesn't. We need to add a little bit of extra data to this tile map to tell the computer what it can and can't walk through. And so if you click this sort of 3D bar of chocolate kind of shape over on the left, that brings you into the wall editor. And every time you draw a red square, it's telling the computer that the sprites can't travel through this part of the map. So I'm just going to cover every bit of wall with a red wall. Okay, and that's it. We can click done on that. We just need to make sure that every bit of wall that we've drawn has red around it. Has red on top of it. Let's click done. Let's have a look at what our simulator is showing at the moment. Always takes so long to load. Come on. You can do it. There you are. So that's what we've got at the moment. I'm not sure how well you can see this, but you can see our cat currently is kind of in the middle of a wall. That's going to be quite painful. Let's move the cat so it's not standing in the middle of the wall. So if I go to sprites, in the physics section, I've got set my sprite position to 0, 0. Let's drag that block in and see what happens. Where's my cat now? Well, if you look in the top left, you can just about see the cat. That's because that position there is 0, 0. So we need to get it into the exact middle of this room. How are we going to do that? Well, if one of these blocks is 16 high, 16 pixels, then two of these blocks are going to be 32 pixels. So I need to move my cat down 32 pixels and right 32 pixels. So where it says set my sprite position to X 0 and Y 0, I'm going to change that to 32 and change that to 32. Now, there's a little bit extra to this. We need to add some value onto those two 32s. And the reason being is if I go into our sprite, we can see that our sprite is 14 pixels high. And when you tell a sprite to go to a position, it's talking about the middle of the sprite. Every instruction about moving places is all centered around the center of the sprite. So if we move 32 down and 32 across, we also need to move down another 32 and across another 30. Sorry, my mistake. You need to move down half the height of this sprite. This isn't usually a thing you have to worry about a great deal amount, but this is just for this application. What we need is we need our sprite nice and square in the middle of the maze. So I'm going to basically take that number and I'm going to add 8 to it. That's going to be 40. And that's going to be, not 3,240, that's just going to be 40. And when I look at my simulator, it should show my cat exactly in the middle of that room. And yeah, that's we're nearly ready to go making the cat move about. But first, let's think about what happens if our cat moves off the side of the screen. Well, the way to fix that is we can have the camera follow the cat. And if you go to Scene and scroll down to the very bottom of Scene, you can have Camera Follow Sprite. And that's the block that we want. Camera Follow Sprite. Right. We've set up our map, we've set up our maze, we've set up our character. Now we need to get it to move. Now, if we were making a different kind of game, we'd actually move the cat ourselves by pressing buttons on the keyboard or on the controller or anything like that. But we don't want to move this by having a user move it. We want the cat to move on its own. So we have to do slightly different rules when it comes to moving. We have to change the cat's velocity. So over in sprites, we have this option to set my sprite velocity to Vx and Vy. That's the block we want to use, but it's not very sensible, is it? I mean, what direction is Vx 50, Vy 50? Who knows? Let's just run it and see what direction it is. Okay, I don't know whether that was easy to see, but that is going diagonally down to the bottom right. That's not what we want. So we could just use copies and copies and copies of this block, but it's not very easy to program. When it comes to programming, it's all about making life easy for yourself. And we're going to do that by making 4 functions, and these functions are going to move the directions for us. So I'm going to get rid of that block because I don't need it for now. And instead, I'm going to click this Advanced tab in the bottom left. And it gives us a load of extra features, but we want functions. And we want to make a new function. And I'm going to create a function that allows my cat to move left, and then one to move up, one to move down, one to move right, and so on. So functions, make a function. And I need to give it a good sensible name, so I'm going to call this go left. And click done. And there we have it, a new function to play with. I'm just going to drag it around to give you some space. We got the function go left. So what do you think we might need in this? Well, we need to change the velocity of the cat. So go into sprites, and we've got to set my sprite velocity to Vx, Vy. Now, when it comes to arcade.makecode, when it's directions, X is left to right, and Y is up and down. But there's a little bit more to that. When you want to go left, it's minus X, and when you want to go right, it's plus X. So we want to go left, so rather than going 50, I need to go minus 50. So it's going to go left, it's going to go in the other direction to positive 50. And when it comes to Y, well, we're moving left here, and when you move left, there's no up and down movement, you're just going straight away left. So we're going to change that to 0. So in your go left function, you should be setting the velocity to minus 50 in the X direction and 0 in the Y direction. And once we've got that basic bit of knowledge, we can start writing the rest of the functions. So let's write a function to go right this time. Functions, make a function, go right. Click done. MakeCode always puts stuff in places that are annoying for me, but I'll live with it. Now, if going Vx left is minus 50, then going right is going to be positive 50. So I'm just going to duplicate this velocity block, pop it in, and change that to positive 50. So I've got going right. Now let's add a little bit more. We need one for going up and we need one for going down. So make a function, go up, put it in a better place, and we want to duplicate this velocity block. Now, when it comes to going up and down, well, up and down is in the Y direction, so we don't want to move any amount in the x direction, so I'm going to change that to 0. And if we want to move up, well, up is minus y, so I need to choose a nice minus number here. I'm going to go minus 50. Right, let's add a little bit more. Let's go functions. Final function, we're going to make one that goes down. So go down. Oh, and it's finally put it in the right place for me. Again, we're going to use this duplicate block. We're going to duplicate this velocity block. And rather than going minus 50, in the y direction, we want to go positive 50 in the y direction. So that should make our cat go down. So we've got 4 functions now: go down, go up, go left, and go right. Now we've written those, we don't have to mess around with the velocity block ever again. We can just use, we can just call these functions. We don't have to bother working out which direction's left, which direction's right, and so on. We can just do it. So let's go back to our onStart function. Wait for the simulator. Is it going to load? There we are. Now, we want our cat to start moving. Doesn't really matter which direction it starts moving, but just for purposes of simplicity and just so we can get on and get this done relatively fast, I'm going to have my cat move right. So, we've made a function called goRight. It's time to call it. Let's go to functions. And we've got the option to go right. Call go right. And I'm going to stick that on the end. So let's have a look at our start block. It creates a sprite. It creates a tile map. It sets the position of the sprite, tells the camera to follow the sprite, and then it calls the go right function. And if we jump over to the go right function, it tells my sprite to move right. And let's see that in the simulator. And there we are. Once again, my cat moves right. Simple enough stuff. We've done something similar before. It's nice and easy. This is where we start adding a little bit of more interesting stuff. We start adding a bit of the logic that allows it to be able to find its way to the end of the maze. Now, to be able to do that, we need to see where it's been, what path it's travelled. So I'm going to add a little bit of code that makes the cat, it could be a robot cat, I don't know, makes the character drop a tile behind it as it goes along, a bit like Hansel and Gretel's breadcrumbs. It leaves a trail behind it. So if we go to scene, and we scroll down, we've got this block called onSprite of kind player overlaps something or other at location. And what that basically does is my sprite touching a tile? And you specify what tile it's touching. I'm going to use that block, and I'm just going to leave it on its own because it's that kind of block. And so what we want it to do is, my cat walks onto a tile. This little bit of code starts running immediately and says, okay, cat, drop a tile behind you. Change the tile underneath you to be something else, to show that you've been there and visited there. And this is where our floor tile comes in. You remember at the start I asked you to choose one floor tile and stick to that floor tile? Well, if I go over to here, this is where I should select it. This is the list of all the tiles I've used so far, and I wanted that floor tile. So if my player is standing on a floor tile, I want to change that floor tile to be a different kind of tile. So in scene, if you scroll down to the tile section of scene, you can find this set tile at tile map column 0 row 0. It's a little bit of a sort of wordy command, but we're going to use that and we're going to change it a bit. Okay, so before we can carry on, we need to make sure that we have included our breadcrumb tile. At the moment, if I click down here, the only tiles I've got available are the floor tiles and the wall tiles. But I want a breadcrumb tile, so we're going to add in our own breadcrumb tile. And you can change that by going back to the start function on start, and where it says set tile map to whatever you drew, we can change that. And this is where we can choose a breadcrumb. And choosing a breadcrumb is as simple as picking a nice looking tile. Let's say let's go for that one. Place the breadcrumb tile once on the tile map and then delete it. It's a little bit odd, but it's all because we have to tell the computer that we're actually going to be using that tile. And the only time it counts a tile as being used is if it's been placed at least once in this map. Okay, let's click done and go back over to our on sprite of kind overlaps function. And now we can see that my breadcrumb tile is available in that list. It's a little bit of a nasty workaround, but hey, it works. So we're going to change the tile underneath the player to this sort of diamond pattern, but where are we going to change it? If we change it as 0, 0, that'll be the one at the top left. So we don't want that bit of code. Where it says tile map column 0, row 0, we need to replace that. And what are we going to replace it with? Well, luckily, this onSprite kind player overlaps tile at location function gives us the location of where this happens. It sort of gives us the, well, where it happened, basically. And so we're going to grab that location block that's sitting right there, just in function, and I'm going to replace the tile map column row with location. And there you are. At the sound of a pop, it just disappears. So it's going to set the tile to be the breadcrumb tile at the location of the player. Let's see if that works. I'm going to screw up my words and load the simulator. Come on. There we are. And let me just zoom in on that. Every time the cat moves to a new tile, it drops a breadcrumb behind it. Right. Now, this is where we're getting into the real logic of it. And this is quite a complex function, so I'm going to try and go slow. As always, if you ever get lost, you can always rewatch this stream back on the Technoclub's website, or at the end I will be uploading the code so you can see for yourself and load it and have a little play around. So don't worry if you get lost. What I want to do now is, say my character has walked through the maze and it's come to a junction. What's really happened is it's hit a wall. Oh, someone's just asked on Discord, Reese, you say your tile isn't being set. Have you made sure that in your onSprite of kind player overlaps function that you've chosen the right floor tile? Now, it can be any floor tile you like, but once you've chosen one floor tile, you have to stick to that floor tile. Oh, there you are. No worries. So yes, where was I? If we go to scene and we look for the on sprite of kind player hits wall, that's the one we need, because what happens when you hit a junction, it means there's a wall in front of you. You've got a choice. Do you go left or do you go right? So we're going to use that. On sprite of kind player hits wall. What should my player do when it hits the wall? Well, it should decide, can I go up? Can I go down? Can I go left? Can I go right? Let's see. Let's see how we go about doing that. Well, first things first, when it hits a wall, it should just stop. You don't want your character to carry on walking through the wall. We want our character to just stop still where it's standing. And the easiest way to do that is set its velocity to 0. So if we go to sprites, set my sprite velocity to Vx, Vy, and I'm going to change those from being 50 to being 0. So my sprite just stops where it is. Next thing up. Well, this is where the logic gets a little bit dense. We need to say, is there an empty floor tile somewhere next to me where I can move to? And for that, we're going to have to get a little bit deep down in if statements. So we're going to get our first if statement. So in logic, our conditional if. And this is where we tell whether or not our character has tiles around him that are not the floor tiles. It's a little bit. Have you ever, had someone talk about double negative? It's a little bit hard to get your head around. What we're looking for is it the case that the tile next to my player is not a floor tile? Let me simplify that. Let's go to logic and let's scroll down. And near the bottom of logic, you can find this little not block. And what the not block does is it takes anything that's inside it and turns it to the opposite. So if you tell the not block, say, not true, well, not true is going to be false. But if you say to the not block, not false, well, the answer is going to be true. And we call this Boolean logic. So, not. So, how do we say my character does not have a floor tile on its left? Well, if we go to scene and we scroll down to about, pretty much near the bottom, we've got this block called tile to left of my sprite is something. This is how we tell what tile is around our sprite. And we can tell it whether it's left, right, top or bottom. And I'm basically going to just grab that. And I'm being very careful here to stick it inside the not block. And we're talking about the floor tile here. So this is where we click the drop-down arrow and we set it to our floor tile. So if there is not a floor tile to the left of my player, we're going to do something. Basically, what it's saying is, if there is a breadcrumb tile or a wall tile to the left of my player, don't go that way, go somewhere else. But if there is a floor tile to the left of my player, well, coming on to that. At the moment, let's just get it to do some dummy thinking for us. It's not going to actually do any logic, we just want to know what's going on. And if you scroll down, inside the advanced menu, you can find this option for console. And in console, you find this console log option. And basically all that is doing is it's giving us, the programmer, a message that the person playing the game can't see. So in here, I'm going to type what it means when there is not a floor tile to the left of the player. It means we can't go left. Let's test that out, actually. Yeah, let's test that. Let's go open the simulator. Wait for it to load. Come on, there we are. Let me restart that. So I've just paused the game for a moment. What should happen is my character should walk to the right, and it should stop here because it hits a wall, and it should say, okay, can I go left from this position? And you'll see that the tile behind the character is a breadcrumb. It's not a floor tile, it's a breadcrumb, so it means it can't go left. Let's click run. Okay, so it's stopped. And if I close that down from full screen and go to show console simulator, we'll see that the console has told us that the cat can't go left. And it can't go left because there is a breadcrumb tile to the left of the character. Okay, let's go back. And basically what we need to do now is we need to do that for up, down, and right. We've got it for left, now we need to do up, down, right. So, because I'm lazy, and being a programmer is all about being as lazy as you can get, I'm just going to duplicate this entire if statement. Just click on it once, then right click and duplicate. And then I go in and change all the values. So we're not having tile to the left this time, we want tile to the top. So the tile above the sprite. And let's change that from can't go left to can't go up. Okay, duplicate again. Right click duplicate. Stick it underneath. Making sure it's going exactly underneath but still inside the on sprite of kind player hits wall block. This is the third one, so this is going to be right. I'm going to change that to right. Let's duplicate again. And change that one to bottom. Bottom represents that the player can't go down. Let's see what happens now. So I'm not going to maximize it, you've seen it before, but the cat walks into the corner and then it decides where it can go. So where can the cat go? Let's have a look in the console. Well, the cat can't go left because there is a breadcrumb block. It can't go up because there is a wall block. And it can't go right because there's another wall block. So what does that mean? It means that it can go down. If it can't go left, can't go right, can't go up, it must go down. Sounds a bit like, what's the name of that? We're going on a bear hunt. I think, can't get over it, can't go around it, can't go up through it. No, can't go under it. Never mind. I'm rambling. Ignore me. I'm just an old man. Going on a bit of a rant. Okay. So we can tell where it can go. Now we need to actually store that as a value somewhere. We need to actually make a note of which way it can go. And so for that we're going to need variables. And we're going to need 4 of them. 1 for each direction. So I'm going to go into the variables block, variables menu, and make a new variable. And this variable, I'm going to call it something sensible, like can go left. So that variable is going to store whether or not the cat can go left or not. So can go left can either be yes or no, true or false. Let's make another one. This one's going to be can go right. Now we need another one, can go down. Ooh. Oh, what's going on? There we are. Can go down. And finally, can go up. Now, at the very start, where the player first hits the wall, we don't know whether or not the player can not move in a different direction. We don't know whether it can or not go left. We don't know whether it can or not go right, and so on and so on. So we need to tell these variables that it is possible for everything to happen, for all of it to happen. So we need to initialize these variables all to true. So we're going to have our character assume that it can do those things. So if I go into variables, I can set a variable. So let's set can go up. And I want to set this to true. Now, the best place to find that, is, as in the only place to find that, so if we go into logic, and we scroll to the bottom of the logic menu, we can find the true block and the false block. We want the true block. And I can stick it in there. So can go up, I've set to true. And now I need to do that for can go left, can go right, and can go down. So set can go left, logic, scroll to the bottom, logic, and there is true. Talk amongst yourselves whilst I do this. This is going to take a bit of a while. I could just duplicate everything. In fact, why aren't I duplicating everything? Just duplicate, stick it underneath, change that to can go down, set it to true. So at the very top of your on sprite of kind player hits wall, you should have a nice set of 4 variable setting blocks. Each of them say true, and each one holds in it a different variable. Now, what should happen if that's not the case? Well, when we can't go left, we need to update that variable, telling our little character that it can't go left. So I need to go into each of these if statements, and I need to set the variable that's relevant. So in this case, left, I need to set it to false. So I'm going to grab another set block, and I'm going to change that to can go left, and I'm going to change that to false. So whilst you do that for the rest of them, let me just read through this little bit of logic. If there is not a floor tile to the left of the character, that means that it can't go left. So we tell that to the console. And that means that we set the can go left variable to false. What's false with can go left? Well, the false with can go left is can't go left. We're telling our computer that we can't go left. And we need to do that for the rest of these. So I'm going to right click on this and duplicate. And duplicate. And duplicate. I've done something slightly dodgy in that rather than changing the values each time I duplicate, I just duplicated all 3 of them in one go. That can really mess you up because it means you might forget to change a value somewhere. Copying and pasting, I'm sure, is responsible for 80% of errors in computer science. Let's change can go left. Let's change that. This one's for top. This is inside the top. checker or if statement. So can go up, set to false. Can go right, so change that to can go right, set that to false. And can bottom, can go down, set that to false. Now we've set those values, but we haven't done anything with them. So let's go on to the next part. This is where we get even more if statements. It gets really messy, but that's just the nature of computer science. You need to get friendly with the if statement. Okay, so I'm going to go to the logic, and I'm going to grab a new if statement. Has my mouse broken? No, there we are. Ugh, it's messing me around. Bloomin' computers. Anyway, this new if statement that I've just created, I'm going to stick directly underneath all that logic that we've already written. Notice it's still inside the grey on sprite if kind player hits wall block. And this is where we're going to tell what the values of the variables are. So what I'm going to do is I'm going to go to logic and I'm going to grab a comparison block, because what we're doing is a comparison. We're going to compare each of these variables, see whether they are true or false. Now, we're going to be checking each of these variables, and what makes this algorithm interesting is, depending on which order you write this if statement in, actually changes whether or not your character can find the end of the maze. And I'm going to leave this up to you, which one you want to choose. It doesn't really matter, it all depends on the shape of your maze. It's actually a strategy when it comes to solving a maze. If you're in a real-life maze, in a real-life labyrinth, one of the strategies that you can employ is to always turn left or always turn right. Every time you get to a junction, you turn right, you turn left, depending on which one you choose. And some say that can actually help, that gives you more chance at getting out of the labyrinth. And so we're going to implement that here. You can have it so that the character goes up or down as well, but you need to choose a direction. Choose left, right, up or down, and that's going to be the one that they favour, the one that they always go for. I'm going to choose left just because. And basically, I want to say is can go left. If that is true, then I need to go left. So let's grab can go left, and we're going to stick it in the comparator. And this is always annoying. It's not going in the right slot. Come on. Come on. Bear with. Every now and then, MakeCode just gives me this nasty error. There we are. Okay, we need to tell whether or not can go left is true. So I'm going to go to logic. I'm going to scroll down. And if can go left is true, then that means that my character needs to go left. And how do you do that? Well, if you remember back at the start, we made a function called go left. So functions go left. So if my character can go left, it's going to go left. What happens if it can't go left? Well, that's where we need to add in the new logic. If we click this plus icon at the bottom of that if statement, it'll create an else block for us. We don't want else, we want else if. So I'm going to click that plus twice. So making sure that your if statement looks like this. If, else. We're not going to use else for now. We're just going to use else if. And basically we do exactly the same, but for a different direction. And this is where you can customize your pathfinding algorithm. You decide which order that the computer prefers to turn. So let's say our computer hits a wall, our character. Our character's going to say, okay, if there's an open space around me, I'm going to, first of all, go left if it's free on the left. If I can't go left, then I'm going to have to go, let's say, down. If I can't go down, then I'm going to have to go right. And if I can't go right, I'm going to have to go up. And it's all about the order of these, which one you have first, that makes the difference about the algorithm. So I've got, it can go left first. I'm going to duplicate that whole comparison block. And I'm going to change that from can go left to can go, let's say left is most important. Next is up. Let's go can go up. If can go up is true, then I should go up. I need more, so I need more else if statements. So I'm going to click the plus icon at the bottom of if. And I'm going to duplicate the comparison. And rather than can go up, let's say can go down is the next most important. And for that, I need to call go down. Let's add another. So click plus at the bottom to bring up an else if. And I'm going to duplicate that bit of code. And finally, functions. This is going to be go right. So functions call go right. Now what happens if our character gets stuck? What happens if they can't go left, they can't go right, they can't go up, they can't go down? What do they do? Well, this is... yeah, I'll save that to the end. But for now, let's just have our character tell us that it's stuck. Let's go to sprites. And if we scroll down to round about halfway, we've got this block called my sprite say smiley face. Except we don't want it to say smiley face, we want to say I'm stuck. Okay, let's give that a go. Let's just run everything. I think that's everything that we need for now, yeah. What we need is the simulator to load. Come on. Stop thinking about it. There we are. Okay, stop that. Let's have a look at what our cat does. So it gets to a wall and it decides that it's going to go down. And it carries off into the distance. And there we are, it gets stuck. So you see how it favoured turning left every time. When it hit this wall, it could have gone right, but no, it decided to go left instead. Let me just show you that one more time. Can't go left, so it goes right. Has to go left. Hits the wall, can't go left, goes right. Goes left, then gets stuck. Because it can't go down because there's a breadcrumb block in the way. Now, that's pretty much it for the algorithm. Let's flesh out the maze just a little to make it a little bit nicer. Let me show you where that was. Remember, it's in the on start block. And just to access the tile map, we can click on this here. Not miscellaneous, I want dungeon. There we are. Let's add in a quick junction there. So you can go left or right. Let's have a dead end. Let's see what happens when we get a dead end. Let me just finish that off. Of course, you could spend ages drawing the most brilliant dungeon and maze, but I'm lazy. I don't have all the time in the world. I've only got an hour, so let's just wrap it up here. Okay, it's a very basic maze. Oh, hang on, I forgot to draw the walls. Remember, the walls are very important for this part. Draw walls. Oh, we don't want walls there. Okay, let's see what happens. I can guarantee you it's going to get stuck. It's going to go left here. Can't go anywhere else and get stuck. Now, obviously, if you did that in a real maze, you would starve to death. You'd be stuck. What's the point in getting to a dead end and not going backwards? So that's a little bit of a interesting part when it comes to pathfinding, the study of solving mazes. What do you do when you get stuck? Well, I'll leave that up to you to solve. It's a little bit involved. It's a nice challenge. I'll give you a hint though. It requires saving the location of the last time you made a decision to move somewhere else. Yeah, think about that. If you want a little bit of a less difficult challenge, you could have it so that you have a special item in the maze, so that when you hit that item, that's the end of the game. You've exited the maze, you've won. Well, the computer's won. And the reason I bring this all up is because, well, pathfinding is very interesting. It's quite an exciting area to explore. And if you go to this link, which I'll be pressing the wrong button for, pasting into chat as well, you can actually see some examples of really advanced maze algorithms. So in this simulator, you've got a green block and a red block. The green block is where the character starts, and the red block is where the character is trying to reach the exit of the maze. And if you draw on this grid, you can actually make a maze. So, actually, yeah, let's complete that. Which do you think will be faster? Does the character go left here or does it go right? Well, if you click Start Search, we can see that it's decided to go around the left. And different algorithms will do that in better ways. This one takes ages. It's exploring all that it can, and there we are, it gets it. That one was quite fast. That one was even faster, and so on. So these ones are a little bit more advanced than the ones we just did, but they're nonetheless, well, pretty exciting. And if you want to look them up, then be forewarned, they're difficult, but they are great fun. Anyway, I hope that has been interesting for you. Let's just do another, just scatter it everywhere, see what happens. I think that one's going to take ages. It's jump point, isn't it? Yeah. was thinking about it. There we are. So the fastest path was going around that way. Anyway, I'm going to stop playing with this now. It's too much fun. Don't forget to check out the Technoclub's website for new activity packs. There's always more being uploaded. You can always come back and rewatch the stream another time on there as well. And look out for the code that I'll be pasting if you got stuck. Now, as always, I'm going to stick around for a bit in case anyone needs a hand. In any case, have a wonderful evening, and thank you very much.